It's been wonderful to see an increase in the number of people who are watching the whole video. There's lots of ways I know whether or not you're watching the whole video, whether you've completed the secret mission or whether you've submitted all of your work. Please do make sure you are completing all of the work that you are set. Without further ado then, I'm going to share my screen and we're going to get started with today's lesson. Before we begin, you are going to need a ruler today in order to draw tables on your piece of paper. So please can you make sure you have a ruler ready so that you can draw them. You'll also need paper and pencils. Today, I'd really like you to focus on making sure you're completing the questions during the input. Please make sure as we're going through the video, you're answering all of the questions on your piece of paper. This means by the end of the lesson, you will have completed and marked ready to upload the morning arithmetic questions, then the morning reasoning questions. Then, throughout the video, there will be 22 different questions for you to have a go at. This is like in a maths lesson when your teacher is asking you questions or asking you to write things on your whiteboard. It's an excellent way for you to have a practice of the small skills before it's time for you to do your independent work. So, hopefully you'll see now, if you're just uploading the questions from the worksheet, there's not actually all of the work you've been asked to do. There's also the arithmetic, the reasoning, and today, 21 input questions. I'd like to share with you some work from someone in Oxford class. This is Lean's work, just so that you can see exactly what I'm talking about in terms of all of the questions. On this first piece of paper that she's submitted, she's done her morning arithmetic and morning reasoning questions. They have been carefully marked and, for example, where she's got things wrong, she's corrected her mistakes. The second piece of paper shows the input questions. These are the questions that I ask during the video. I say, pause the video and have a go at this question. You can see she's clearly written the date and Walt at the top of the piece of paper, and she's also completed the do now questions. Then, and only then, is she having a go at her independent work and submitting those questions. So, I urge you all to take a leaf out of Lean's book and try to complete all of the work from your maths lesson. Here are your morning arithmetic questions for the day. So this is your first chance to prove that you're taking your learning seriously. Pause the video and have a go at these 6 questions on a piece of paper. Off you go. Right, we're going to go through the answers now. I know that 48 divided by 6 is equal to 8. Be careful here though, because when it comes to division, you've got to think really carefully about how many zeros there will be. The product has 2 extra zeros. That means between the factors, I need to share 2 zeros. 60 already has 1 0, so there's just 1 0 left for the 80. If you said 800, you weren't thinking carefully enough about how the zeros need to be shared between both factors. 3 6 of 42. 42 divided by 6 is equal to 7, and then 7 times 3 will give you 21. For this question, you're looking for KFC, so that would be 3/6 to keep. 1/6 once you flipped it and then change that to multiply. You're left with 3 over 36. That could actually have been simplified to 1/12 if you wanted, but that part wasn't needed. The next question has lots of different things to do. First, I'm going to make that a top-heavy fraction. 1 times 4 is 4, add 5. That gives me 5/4. So now I'm doing 2/3, add 5/4. I still can't solve it, so the next step I'll need to do is to make them both have the same denominator. A common multiple of both 3 and 4 would be 12. To get from 3 to 12, I'm timesing by 4. So I need to do 2 times 4, which is 8. And to get from 4 to 12, I need to times by 3. So 5 times 3 is 15. Check if you're adding or subtracting, add them up. 15 add 12. Sorry, 15 add 8. That would give me 23 over 12. This also could have been converted into 1 and 11/12. Okay, for this question, I times by 10 and then times by 10 again. That's the same as timesing by 100. So what I'm actually doing there is 76.13 times 100. That means I need to move the digits 2 spaces. Down, 1, 2. 7, 6, 1, 3. 7,613. To find 40%, I'll start with 10%. 10% is 36. I know that 40% is 4 times larger, so now I'll multiply that by 4. 4 times 6 is 24. 4 times 3 is 12. Add 2 is 14. 144 for that question. Well done. The next work that you're going to complete is this arithmetic work. So take a moment now to complete the arithmetic work. Pause the video and solve these questions. I'll go through the answers afterwards. So the first question asked you to use the digits to make a multiplication sentence where the answer is a multiple of 4. So I need to think to myself, what is a 2-digit number that's a multiple of 4 that I can also use, when I multiply 2, 6 and start that again. I need my final answer to be a multiple of 4. So I need to think to myself, how could I arrange these digits so that it is a multiple of 4? In order to do this, I would simply recommend using trial and error. Or you could say to yourself, if I know it's a multiple of 4, that means it's definitely going to be an even number. So I probably would have done 2 times 76. Double 76, or 76 times 2, let's quickly work that over here. That 2 times 6 gives us 12, 2 times 7, 14, add 1, 152. Now, if I want to check if that's a multiple of 4, I would divide that by 4. How many 4s fit into 1? 0, 4s into 15, 3, regroup 3, 4s into 32 is 8. So 2 times 76 was a correct answer. There are possibly more correct answers, but that one works for now. Use these digits to make a multiplication sentence when the answer is a multiple of 7. In a similar way, you need to make sure that you're ending with a multiple of 7. I'm going to think to myself, whatever goes in the ones columns, when I multiply that together, I need that to make a multiple of 7. So basically, if I do 7 times any number, in fact, I'll get a multiple of 7. One of my numbers is 7. I times that by anything, and my answer will be a multiple of 7. 7 times 28, 7 times 82, 7 times absolutely anything will be a multiple of 7. Write down all the square numbers in this list. Go through the square numbers in your head. You should have spotted 16 and 49. Write down all the factors of 48, numbers which multiply to make 48. 6, not 10, not 11, 16. Well, let's think. 16, 32, 48. Yep, 16 is 1. 24, yes, that's half. 30, 40, 49 and 89, no. All the prime numbers. You need to next write down all the prime numbers. 11 is a prime number. Any even number apart from 2 can't be a prime number, so I can get rid of those. 49 I know is in the 7 times tables, so now I need to try and work out whether or not 89 is a prime number. Can you think of any numbers that multiply together to make 89? No, so it's a prime number. Okay, next your conversions, that's 1/10, which is 10%. 0.25, which is 25 over 100 or a quarter. 1/5 is 0.2, 20%. 0.2, is 1/5, 20%. 8/20. I would simplify that to 4 over 10. 4/10 is 0.4, that's 40%. And finally 3%, that's 0.03 and 3 over 100. How many degrees does the ballet dancer need to turn in a full turn? How many degrees in a circle is that? We know a circle is 360 degrees. A half turn is 180. 2.5 turns. So that's 1 full turn times 2, giving me 720. And then add on the half turn. That would give me 900 degrees. You could have also done 360 times 2.5. Both of those would have got you the correct answer. Right. At this point in the video, you have completed your morning arithmetic and your morning reasoning. Now you need to write today's date and what and begin the do now question. For the do now question, you need to be careful when reading the scales, as both scales are slightly different. Please work out what the total amount of water in the jug is. Off you go. So I can see in between 0 and 250, I have 1, 2, 3, 4, 5 increments. 250 divided by 5 gives me 50. I know each increment is worth 50. Now that I know that, I can work out the first jug. 250, 300, 350, 400. The first jug has 400 millilitres. Let's look at the second jug then. Between 0 and 100, there are 1, 2, 3, 4. 100 divided by 4 gives me 25 millilitres. Each jump has a value of 25. I could either count forwards from 200 or backwards from 300. Either way, this is 275 millilitres. So I add those together to get 675 millilitres in total. Okay, today we're going to be talking about the different types of data that you can have and represent in different forms. There are two main types of data. There's continuous data and discrete data. Continuous data is any value including decimal numbers. Continuous data is data that we measure rather than count. For example, we might measure someone's height and we might measure the temperature. The thing about continuous data is, let's say we're measuring someone's height. If one day a sunflower is 8 centimetres and the next day when I measure it, it's 12 centimetres, I know that that sunflower hasn't magically gone from 8 to 12 with nothing in between. In between my points of measurements, I went through every single possible height. So when I measure it, I might get a decimal number in between 8 and 12. So you could do height, you could do temperature, you could do anything which must be measured using a tool. Discrete data then, which is what we're going to be focusing on today, are specific values that can be counted. For example, how many people like the colour blue? I can have 3 people or I can have 4 people, but there's no possible value in between that when we're counting people. I can't have 3.25 people. That doesn't make any sense. So today we're going to be looking at discrete data. That's data which can be counted and it needs to be presented in a specific way. The first way that you might present your discrete data is with a tally. Just going to quickly remind you how to read a tally. Each group like this represents 5. You can see it's created from 1, 2, 3, 4, and then 5. This is to keep the tally marks neat and make it easy to count them. So when I'm counting this as a tally, I would read that as 5, 10, and then each individual one, 11, 12. That's equal to 12. Right. This is your first opportunity to have a go at answering one of my input questions. Please can you write the subtitle underneath where you did the do now of input. The questions today have been numbered so that you can keep it neat and organised. Your first 2 questions you're going to have a go at, as though you're in my maths lesson and doing them on a whiteboard, is what is the total of tally number 1 and tally number 2? Just write down your totals on your piece of paper. Pause the video now to solve those questions and get yourself organised. Okay, going through 5, 10, 15, add 1 more, 16. Please mark if you got the answer 16. Give it a tick, and if you said something different, please rewatch the video to see how you could have done it correctly. For number 2 then, one group of 5, 6, 7, 8. Input question number 2, the answer was 8. Right, so for this question here then, I'm going to do the first part, you're going to watch me do the first part, and then you're going to have a go at question 3, 4 and 5 on your piece of paper. The first part says complete both tables. The reason why I have to do this section is you won't be able to do it on your piece of paper. First, I need to know the frequency, the difference between a tally and a frequency table. A tally is what you do when you're recording the data during the experiment, and it's done very, very quickly with the lines. Once you've finished, you could count up the tally into your frequency. That's the number. The second difference is a frequency table contains the total at the bottom. So that's what I'll have to do when completing this table. So the frequency for Amanda, 5, 10, 11, 12, 13, 14 was 14. For Bernardo, I need to say what 6 would be in a tally. Quickly think how you do that now. I need to show 1, 2, 3, 4, 5, 6. Quickly count up Charlie's and see if you get the same as me. 5, 10, 15, 16. Charlie got 16. Destiny, I need to show 3. I'll just do that as 3 lines. 1, 2, 3. How many was Amanda? 5, 6, 7. Sorry, Eleanor was 7. Now, the final thing you need to do to complete a frequency table is to calculate the total. I need to add up 14, 6, 16, 3 and 7. Can you see any quick and easy number pairs that will be easier to add mentally? I can see 2 pairs that I'm going to do. Have a look now. I would add up 3 and 7 to make 10, and I would add up 16 and 14 because I know that these are number bonds to 10, so 16 add 14 is equal to 30. 10 add 30 is 40, add this 6 here that was lonely, and that will be 46 in total. Think carefully about which way you can do your mental addition when you're finding your total. Look for those number bonds to 10 to make it quicker. Okay, you're now going to pause the video and answer these 3 questions here. This should be on your piece of paper underneath where you've already solved those 2 questions, underneath the subtitle input. Pause the video and answer these 3 questions. Question 3 says, how many more? We know that how many more means we're going to subtract. How many more dojos did Amanda get than Destiny? Amanda got 14 and Destiny 7. 14 take away 7 is 7. Who got the least dojos? Destiny only got 3 dojos, unfortunately. So she got the least. How many dojos did Charlie and Bernardo get? All together we're looking for there. Charlie got 16 and Bernardo got 6. Add that up and you have 22. Please make sure you've marked these 3 input questions. We're going to move on now to look at pictograms. When you've got a pictogram, the key piece of advice is to always start by checking your scale. Here, my scale says 1 star equals 10,000. That means half a star, I really can't draw half a star, can I? Half a star will be half of 10,000. Half of 10,000 is 5,000. Okay, and you can also see you may end up with quarter of a star. Quarter of a star would be worth 2,500. So what would 3/4 of a star be? What would 3/4 of a star be? Have a little think now. Yep, it would be 7,500. Okay, the first question then I'm going to do, because it's in red, that means it's a question for me. How many stars are there in all 4 galaxies combined? What I'm going to do here is add up all of my complete stars. That's 1, 2, 3, 4, 5, 6, 7, 8. I'm then going to see if I can make another complete one. If I put this quarter with this 3/4, that gives me 9. 9 groups of 10,000 is 90,000. And then add my incomplete stars, half a star. If 1 star is 10,000, half a star is 5,000. So 9,000 add 5,000 is 9,500. Okay, sorry, 90,000, 95,000. Sorry about that. So please do make sure when you're adding up your total on a pictogram, you start by counting your whole pictures and then you add on the fractions of them. Okay, so for your next questions, you are asked, how many stars are there in the Andromeda galaxy? Again, count up your wholes and then count up your parts. How many more stars were there in the Whirlpool than the Messier 81? And which galaxy has the most stars? Please pause the video now and answer these questions on the piece of paper underneath the subtitle Input. Now I'm going to go through the answers. Andromeda. That's 10,000, 20,000, and then remember 3/4 of a star we said was 7,500. So Andromeda, that's 27,500. How many more stars are there in Whirlpool than Messier 8? Start by counting Whirlpool, 10,000, 20,000, and this quarter star is 2,500. So that's 22,500 for that one. Messier 8 is 10,000, and then a half star, which I know is 5,000. So that's 15,000 in total. Subtracting the 2 would give, sorry, don't know what I've done there. Subtracting the 2 would give me 7,500. Finally, which galaxy has the most stars? Not how many stars, just the name of the galaxy. I can see the Milky Way has the most stars because there are 3 complete stars making it 30,000. The Milky Way has the most. Well done if so far you've done 8 independent questions under the input and you've marked them all. Right, have a look at this. I'm just going to explain to you which bits you're going to do and which bits I'm going to do. The red questions, 1, 2 and 3, I'm going to do them in order to show you. Then on your piece of paper, you're going to have a go at question 9, 10 and 11. You're just going to write them down on your piece of paper like this, whatever you'd put in the table as number 9, 10 and 11. I'll show you on the left what I mean by 1, 2 and 3. So in question 1, I'm looking for what frequency should go in this part of the table. When we're looking at how many people had how many siblings. I know a full circle is worth 4, a half circle then must be 2, and a quarter circle must be 1. Let's add up how many people were in total in number had 1 sibling. That's 4, 8, 12, 16, add 1 more, that makes 17. So for question 1, I'd write 17. Right, number 2 is here. I need to draw the frequency of 10. Each circle is worth 4. So that's 4, 8. Can I do another full circle to make 12? No. I need another 2, so I'll draw a half circle. So that's what I'd write for number 2, like that, 2.5 circles. And now again, I need to draw for number 3, the frequency there, which is 15. So I'm going to count in my 4s. 4, 8, 10, 12, and then I need another 3. That would be a 3/4 circle like that. So I'll put that for number 3, 1, 2, 3, 4, and a 3/4 like that. Okay, so on your piece of paper, can you do question 9, 10, and 11? Pause the video and solve question 9, 10, and 11. Okay, here's question 9. We were looking for how many people are in number 3. That's 4 and then a half, making 6 in total. Question 10 was down here. We wanted to draw the frequency that goes with 3 siblings. How many should I draw here? So I need to show 3 siblings. That's not a half, it's not a quarter, it's a 3/4 circle. Well done if you drew your 3/4 circle like that. And finally for 11, you needed to draw enough for 1. That's a 1/4 circle there. Okay, now we're going to be looking at bar charts. I'm going to do these 2 questions as you won't be able to draw them because you don't have the bar graph in front of you. But watch how I'd solve it because you might be able to need to do this question later. Always start by checking the scale. I can see on the scale I'm going up in 2s. Kingston spent 13 minutes reading. Draw their bar on the graph. If you're ever asked to draw a bar on a graph, you must use a ruler. Right, so I need to show for Kingston class 13 minutes. I'd go to 12 and then in between 12 and 14 would be 13. Limerick class spent half as many minutes reading as Liverpool. Right, let's read how many minutes Liverpool spent reading. I find Liverpool and I read up. Then I go along to the x-axis and I can see that is 20. Half of 20 is, of course, 10. So from Limerick, I'm going to go up until I find 10 on the y-axis. There we go. There's Limerick's bar. Right, now using this data that we've just gathered and completed, you're going to answer the following questions. Please can you pause the video now and on your piece of paper where you're answering your input questions, have a go at answering questions 13 to 17. We'll go through them afterwards, so any questions you found difficult, you'll be able to know how you could have solved them. Pause the video and answer those 5 questions. Okay, question 1. Which class read the most? You can see that Liverpool and Oxford read a lot, but Oxford just got slightly more with 21 minutes. So we put Oxford there. Which class read the least? Well, you can see here the smallest bar is in fact Limerick. How long did UCL read for? Again, I'd go to UCL and I'd read across really carefully. In between 14 and 16, that's 15 minutes. How many more minutes did Liverpool read than Sheffield? We know Liverpool read 20, and let's see how many Sheffield read for, 12. How many more means subtract? 20 take away 12 is 8. How many minutes did UCL and Kingston spend reading together? That's going to be adding. UCL we know read for 15 minutes, and Kingston here we know read for 13 minutes. Add them up and you've got 28 minutes in total. Well done if you completed and marked those 5 questions. Sometimes in your bar graph, you may see different colours for each person. For example, here you can see under Oxford, there's writing, maths and computing. The same for UCL and Sheffield. This bar graph is showing us which subject were the most popular in each class. Don't forget, you always start by checking the scale, and on this scale I can see I'm going up in 2s. All right, so the first question asks me, what was the least popular subject in UCL? I go to UCL and I see which of the 3 subjects has the smallest number of people. It is the writing, which has only 5 votes. So the least popular subject is writing. How many children were surveyed in UCL class? In order to answer this question, I need to know how many children voted in total. 5 children chose writing, 10 children chose maths, and in computing it was 7. So how many children were surveyed? I'd add that all up. 10 add 5 is 15, add 7 is 22 children. You're going to pause the video now and have a go at solving these 2 questions on your piece of paper underneath the subtitle input. You're now on question 17 and question 18 of your input questions. Don't forget to pause the video and answer those 2 questions. Okay, so let's add up how many children were surveyed in Sheffield class. There's 10 who chose writing, For maths, it was 7, and for computing, it was 12. Add that up all together and you will have 29 children. What's the least popular subject overall? Now, it would be a mistake to just look at the bars and guess. This is a maths question, therefore we assume there's going to be some maths involved. What I'm going to do is write the total of each one and then find the total number of children who voted for each subject. So for writing, that's 7 add 5 add 10. 10 add 5 is 15, add 7 is 22. For maths, I would do 13, add 10, add 7. 13 add 7 makes 20, add 10 is 30. And for computing, I would do 7 add 7, which is 14, add 12, making 26. The least popular subject was writing. Okay, at this point in the video, I'm going to give you your secret instruction for today. Next to or underneath where you've answered question 18, I'd like you to write down what your favourite subject is and why. So, I repeat, your secret instruction today, which you'll only be able to hear if you've watched the whole video carefully, is to write down what your favourite subject is and why. For example, I might write down, my favourite subject is writing because I can be creative and express myself. Right, let's move on with the maths and we'll see who has done those secret instructions. Okay. For these questions, these are bar graphs, but you'll see they're represented vertically rather than horizontally. I am looking here. First, I need to start by checking my scale, 0 to 10, and each smaller increment is worth 2. Right, you can see here, you've got them on top of each other. Here, this is a chart to show how children travel to school. Year 6, you can see, is made of car, walking, and other modes of transport. I'm going to show you how you would answer some questions like this. First of all, it says in year 3, 20 children use other modes of transportation. Add their data to the correct bar graph. I need to add on 20 children onto that bar graph. I'm already at 60. 60 add 20 is 80. So my grey bar would go at the top all the way up to 80. You can see mine has not come out grey for some reason. Let's quickly change that now. Okay, that's question 1. How many children walk to school in year 4? Now, this is where it gets a little bit more challenging. Walking is orange. If I read across the bar here to my y-axis and saw, that should have been done with a ruler, sorry. If I read across here and saw that walking was 45 and I said the answer was 45, I've made a really silly mistake. The walking colour does not start at 0. In fact, walking only begins at 30. So the people who walked went from 30 up to 45. 30 to 45. To find the total there, what I would do is 45, take away 30. That is 15 people who walked. It's not 45. 45 is the total of people who got the car and walked, so be careful with these questions. Okay, how many more children walk to school than travelling by car in year 6? For this then, I'll need to know how many children travelled by car. Let's go to year 6. Children travelling by car is from 0 to 20. This one is just 20. Now I need to see how many children walked. Walk is orange. That's going from 20 up to 75. It's not 75 children. 20 of those children got the car. So 75 take away 20 is 55. Okay? Please be careful when you're doing the bar charts when they look like this, and remember you have to take away whatever comes underneath. All right, so now I want to know how many more children that is. 55 take away 20 is 35. 35 more children walked than getting the car. I'd like you to have a go at these similar questions then. How many children drove to school in year 3? How many children were surveyed in total in year 4? And how many children in year 5 were surveyed in total? Pause the video and answer question 19, 20 and 21 of your input questions. Off you go. Okay, so I'm looking for how many children drove in year 3. I go to year 3 and I'm looking at drove. Luckily for me, that's the first one, so it's easier to read. Read it across like that. From 0 to 25, that will be 25 children. How many children were surveyed in year 4? Well, that's the total number of children, so I just go to the top one, and that will be 65 here. 65 children were surveyed in total. Finally, how many children were surveyed in year 4, and then how many children were surveyed in year 5? Again, reading across like that, 80 children were surveyed in year 5. Okay, At this point, those of you who followed my instructions have done your arithmetic, your reasoning, and 21 input questions. Well done, I'm really impressed. It's now over to the independent work. For the independent work, if you do not have a printer, don't worry. Just draw the tables out on your piece of paper. There's only 3 questions where you will need to draw your tables, and that's why I asked you to make sure you had a ruler handy. For the rest of the questions, you can just answer the questions on your piece of paper. I've put some helpful hints in bright in yellow, and also please do remember to pay attention to which words are in bold and remember the phrases like how many more, how many less. Always look at your scale because that will tell you, and your key because that will tell you how to answer the questions. So I'd like you to have a go now at these 17 independent questions. Pause the video now so that you can answer those questions and then come back to the video to look at the answers. Pause the video now and have a go at those questions. Okay, if you're still watching the video, that means you've done your independent work. Well done. If you haven't yet done your independent work, please do not continue watching the video. Right, we're going to go through these answers quite quickly. Some of them I've already written up. For this one, I know that 1 circle is equal to 2. So to make the frequency 15, I would go 2, 4, 6, 8, 10, 12, 14 and a half for 15. For cows, that would be 2, 4, 6 and a half to make 7. Chickens 2, 4, 6 and goats 2, 4, 6, 8. How many of the animals had 4 legs? Pigs, cows and goats have 4 legs. Chickens only have 2 legs, so I'm not adding them up. 15 add 7 is 22. Add 8 makes 30 in total. What fraction of the animals on the farm are goats? And I gave you a clue and I said simplify your answer. 8 animals are goats. There are 36 animals on the farm. Okay, now you're going to simplify that answer. Both can be divided by 4. 8 divided by 4 gives me 2, and 36 divided by 4 gives me 9. 2/9 should have been your final answer there. Right, for the next group of questions then. How many children spoke other languages? You know there's 2,000 in total, so count up what you've got so far. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,200, 1,300, 1,400, 1,500. A half add 2 quarters makes 1,600. So I need 1, 2, 3, 4. Another 400 to make 2,000 in total. How many more children spoke English than Polish? Well, in English we've got 1, 2, 3, 4, 500 and then a half, which is 50. 550, take away Polish, which was 100, 200 and 25. Take away 225. That should have given you the answer 325. Well done if you said that. The least common language was Polish. What percentage of the children spoke Portuguese? And I gave you a hint. I said write it as a fraction first. That's 400 divided by 2,000. I need to get that to an answer over 100 to turn it into a percentage. In order to do that, I'm going to first cancel out 2 of those zeros and then half it. 20 over 100, that is 20%. Well done if you got question E. It was a bit of a challenge and I'd be very impressed if you did get it. For your next group of children then, I've just popped the answers in for you. Pause the video now so that you can mark this part of the bar graphs question. Okay, the next group of questions here. 5 boys chose science. If you were able to print out the sheet, your bar should have been there next to 5. But if you did not use a ruler, mark it wrong. If you've done it without a ruler, it is definitely wrong. How many girls like math the most? 7. How many children like art the most? That would be the boys add the girls, makes 7 again. Which subject was the most popular overall? Again, you've got to prove it. Science, 3 add 5, that makes 8. Writing, 2 add 4 makes 6. Maths, 7 add 3 is 10. Spanish, 6 add 5 is 11. Art, 4 add 3 is 7. And other, 2 add 1 is 3. I bet some of you said the most popular subject was maths. That's probably because you saw that the longest bar was in maths. However, it didn't say what was the most popular subject for girls, it said the most popular subject overall. And that was in fact Spanish. Well done if you actually worked out the totals for this one. How many girls were surveyed in total? Let's quickly add up the blue bars. That's 3, add 2, add 7. So far we're on 12. Add 5, giving us 17. Add 4, 21. Add 2, 23. I did that quite quickly, so now I'm going to go back and check. 7 add 3 makes 10. 2 add 2 is 4. Add 4 is 8. Add 5, 23. Good. How many year 5 children chose jacket potato? Jacket potato is in blue, so that's nice and easy for me to count. Don't forget to check your scale. It's counting in 2s in the half mark. So if I go from jacket potato here out to here, halfway in between 8 and 12 is 10. How many year 3 children chose beef lasagna? Beef lasagna was orange. You can see orange starts at 20 and it finishes at 32. If you said the answer 32, I think you probably didn't watch the video where I went through how to do this. From 20 to 32, that's 32, take away 20, that's 12. How many more children chose beef lasagna than jacket potato in year 6? So I need to go over to year 6 and I need to see how many children chose jacket potato in year 6. That's a tiny bit, if you saw this, well done, a tiny bit after 4, making it 5. If you said 4, your answer will be different, and I can understand why you did say 4. It's very hard to see that it's a tiny bit after 4. How many people liked beef lasagna, which is the yellow one, so that's from 5 all the way up to 40, that's 35. 35 take away 5 is 30. True or false, jacket potatoes were more popular with the younger children. Looking at jacket potatoes, you can see that those bars are bigger. That is true for the younger children. How many children were surveyed in year 4? The total for year 4, we go to the top of the year 4 bar, take it all the way along, that's going to be 42. In total, how many people had vegetarian lasagna in Key Stage 2? In order to answer this question, I'm just going to take all of these bits. Oops, I don't seem to be able to do that. My paper's got a bit jumbled. In order to answer this question, first you need to find out how many people chose vegetarian lasagna in each year group. Okay, in order to do this, you needed to find how many people chose vegetarian lasagna in each year group. Vegetarian lasagna is the grey one. So on the top, that's from 40 to 46, so that's 6. On year 5, I can see that's from 32 to 40, so that's 8. Year 4, you can see that's from 36 to 42, that's 6. And in year 3, you can see that's 32 up to 40, which is also 8. Add that all up. 6 add 6 is 12. Add 16. 12 add 16 is 28. Right, how many children were surveyed in total? In order to find this one, you'd have to add up all of your totals. So that's 46. Add 40. Add 42. Add 40. For me, I'm going to start by adding my two 40s. 40 add 40 is 80. Add 42 is going to give me 122. Add 46 on top of that will give me 168. 168 children were surveyed in total. Well done if you answered all of those questions, and really especially well done to those of you who also answered all of the input questions. That is the end of today's maths lesson, and well done to everyone who engaged properly. Don't forget to upload your work onto Seesaw, and I'll see you all tomorrow.